The notes for 1.7a on solving absolute value equations. Absolute value is defined as being the distance that a number is away from 0. So if the absolute value of x is equal to 2, there are two numbers that are 2 away from 0. 2 is 2 away from 0, but if you go the opposite direction, -2 is also 2 away from 0. And so this equation has two solutions. X can equal +2 or x can equal -2, and those are the two values that are a solution to that equation. Similarly, there are two numbers that are 9 away from 0. +9 and -9 are each 2 away from 0. So x equals +9 and x equals -9 are the two solutions to that equation. In C, x equals 0, there's only one number that's 0 away from 0, and that's the number 0. So this one only has one solution, x equals 0. And in example D, there are no numbers that are a solution to the equation because the absolute value of x equals -7 doesn't have a solution. We don't measure distance using negative numbers. So in this example, there's no numbers that are -7 away from 0 in terms of the way that absolute value is defined. The absolute value equations will usually have two solutions. So most commonly you're going to expect to get two solutions for these. When will they have one solution? When the absolute value expression equals 0. So anytime you see it set equal to 0, that means it's going to have one solution. And then when will they have no solution? So they'll have no solution when the absolute value expression part of the equation equals a negative number. And so no solution will come up sometimes, so it's something that you want to make sure that you keep your eyes on. When we solve absolute value equations, we want to make sure that we consider that they usually can have two solutions. If the absolute value of x minus 5 is equal to +7, that means that x minus 5 can equal +7, or if x minus 5 worked out to equal -7, we would get a second solution to the equation that was also true. Sometimes students like to draw two little arrows here to indicate that they're solving two separate equations. I'll add the 5 to both sides, so one of my answers will be x equals 12, and then over here I'll also add the 5 to both sides, and so my second equation for this one will be x equals -2. You can just put two separate boxes if you want to around these, or if you prefer you can write them the way that we wrote the answer up above. But this equation has two solutions. The inside can equal +8, or the inside can equal -8. Again, over here I'll solve each of these two separately, and I'll get my two solutions to the question. So x can equal +4, that's one answer to the question, or x can equal -4, that's another answer to the question. The bars are already all by themselves, so the inside can equal +45, or the inside could equal -45. And then I'll go through and solve each of these separately. So x equals 11 will be my first solution, and then I'll go through and solve this one separately over here. So the work for these are not connected to each other. You're solving them as two separate equations. So for this one, my two solutions will be x equals +11 and then x equals -7. Here on D, though, notice that it's set equal to 0. So there is no +0, -0. For this one, you don't need to do two branches, you just need to do one. So you set the inside equal to 0, and then you'll go through and do the steps algebraically to solve for that to figure out what the number is for x that makes the inside part be 0. And so for this one, there's just one solution for this one. So two answers, two answers, two answers, and then this last one just has one answer. When you're solving absolute value equations, sometimes the bar, the expression that has the absolute value, isn't already all by itself, and so you need to do some work first before you split it off to make your two answers, because the bar has to be isolated. So the absolute value expression has to be all by itself before you can split it off to make your two answers. Y equals +3 and y equals -3 are the two solutions that make this absolute value equation true. Similarly on this one, I have to start by minusing the 7 from both sides. The absolute value of x is equal to -2, and so this one has no solution. Remember, when it equals a negative number, that means it's not going to have an answer. Over here, I need to minus the 2 first, because I have to get the absolute value expression. The part with the bars has to be all by itself, and then once it's all by itself, I can split it off and make 2. Equations, the inside can equal +2, or the inside could equal -2, and then I'll solve each of those separately. And so I'll get my 2 solutions here. On example D, I have to start by dividing both sides by 3, because you always have to get the bars, the absolute value expression, isolated first, and then once it's isolated, then you can break it off and make your 2. So the inside could equal positive, or the inside could equal negative of whatever that value is, and then you'll solve each of those 2 equations separately to get your 2 answers to the question. Usually 2 answers to the question. On example E, same thing, I'll start by dividing both sides by that number out front, because I need to get the bars isolated, and then once the bars are isolated, I'll solve. So the inside equals the positive number, or the inside can equal negative of that number, and then I'll solve each of these separately. So my first solution will be x equals +4. And then on this one, I'll get x equals -2. So +4 is one of my solutions, and then -2 is the other. Over here on F, I need to divide both sides by -4 to start. The absolute value of 2x plus 5 is equal to +4. You might have wondered on this one if it was going to be no solution to start, but notice that when you divide both sides by that -4, it turns this value positive, so this one actually will have the predicted 2 solutions. 2x plus 5 equals -4. So the inside can equal positive of that value, or the inside can equal negative of that value. And then just as a reminder, it's okay that these work out to be fractions. A lot of times we pick problems that don't, but it's perfectly okay. And as a matter of fact, on this one, both of your 2 solutions work out to be negative fractions, and that's also okay. On example G, I'll minus the 1 from both sides. So -2 times the absolute value of x minus 3 is equal to -6, and then divide both sides by -2. So the absolute value of x minus 3 is equal to +3. If this 3 were negative, it would have no solution, but this 3 is positive, so that means that it's going to have its 2 solutions that we expect. X minus 3, so the inside equals +3, or the inside could equal -3, and then we'll solve each of these from there. So x equals 6, or x equals 0, and you can get 0 as an answer to the question as well. So those are the 2 solutions for that one. And then last but not least on this one, we'll minus the 2 from both sides. We'll get the absolute value of 4x is equal to -3, and this is when we stop and indicate that the equation is going to have no solution, because the absolute value, the distance the number is away from 0, can never equal a negative value. So that last and final one has no solution.